Share with your group. Henry, what'd you get?
X plus 4 times x plus 4. There's x plus 4 squared.
Oops. Okay. X plus 4 times x plus 4. Or you said I could write it what?
X plus 4 squared.
Do you agree that that's equivalent? I could go either way? Okay. Henry, explain how you got that answer. How did you get your answer?
So I know like the two, I don't know what to call it, like the two like non-x numbers. Like the product of that has to be 16, and then the sum of that has to somehow equal 8. And so like I just thought in my head like 4 times 4 equals 16, and also they're both positive, and so when you add them together it equals 8.
Okay, raise your hand if your thought process was similar to Henry's. Okay, David, did you think something different? Okay, yeah, explain.
Divide by x, the middle number, equates to 1/2, and then you square it, and then it's equal to the value, then it's a perfect square. You can write it in.
Okay, so this is one of those that we sometimes call the special product patterns. And so this fits one of these situations where if I say I have a plus b squared, then there's a particular pattern that says I take a squared plus 2 times a times b plus b squared. Well, when a is 1, or just x, sorry. When the a is just an x, I've got the x squared going on from a squared, and the x is here. So what that leaves me with then is the 2b, and so what David's saying is, if I just divide the number by 2, and then square that to see if I get this, then it must fit this perfect square trinomial pattern. So that's another way that I can think of it, and then I just know it's going to be x plus 4 quantity squared because of the pattern. Okay? So you can use patterns to work this out, or just go back to the old, what are the factors of the constant that add up to b, factors of c that add up to b, and work it out that way. Okay? Either way works. Good. All right, try another one. Okay, check the groups. Okay, Emma, what'd you get on this one? Raise your hand if you agree. Okay. How'd you know that's what you should get from x squared minus 100? Okay, so it's another special pattern, right? So we have two types of special patterns when we talk about this. We have the perfect square trinomial pattern, which is what we just saw a minute ago, and then we have the difference of squares pattern. this is a difference of squares. Our first term is a perfect square, our last term is a perfect square, and so the pattern says we can take the square root of each of these and set up one factor where I take square root of the first term plus the square root of the second term, and then one where I take square root of the first term minus the square root of the second term. Could we go back to what we were doing in the last two examples where we could take the factors of C and add up to B? In a sense, yes, because what would my factors have to add up to?
0.
A 0. If there's no x term there, then that must have meant B was 0. So you could still think of it that way as well. And that would give you the positive and negative 10, which would cancel each other out to give you the 0. Okay? All right. Good. We're off to a good start. Let's step it up a notch. Check with your group. Okay. Julie, what'd you get on this one?
Parentheses 2x plus 5, parentheses, and parentheses x plus 3.
Raise your hand if you agree. Everybody got? Julie, how did you get this?
I first got the factors of 2 and 15, so 5, 3, 1, 15, and 2, 1. And I matched it up with first multiplication and then addition of the two sums.
Okay. So there's a couple of ways to approach problems like this. What's different about this expression compared to the expressions we saw in the last few examples? William?
The A has it's 2x, not like x.
Okay, so our A value out there in front of x squared is something other than 1, right? And so we need to think about not just factors of C that add up to B, we have to think about factors of A times C that add up to B. So we need to take the A times C here, which is 30, and then think about factors that would add up to that. Now, some people will continue with that idea. Other people just kind of use a guess and check. Okay? So they take a look at 2x squared. They know they've got to come up with these two parentheses. So in a sense, you're kind of unwrapping the foil. How's that for an analogy? Because we know we need to get these two parentheses that when I foil it out, it's going to give me this. So in a sense, you're trying to think backwards. What would the pieces have to be so that F, O, I, and L work out? So some people will say, just erase this for a second. Ooh, that's really small. Let's go bigger. There we go. So some people will just say, okay, I know that one of them is going to have to be a 2x and one of them is going to have to be an x for the firsts, because that's really the only way you're going to get 2x squared. Right? Okay? And then they come over here and they go, okay, so in order to get this 15, I'd have to multiply the lasts together. So you think about what are factors of 15. The trick is making sure that you line them up in a way so that outsides and insides would actually work. So yes, you might think, okay, factors of 15 are 3 and 5, but do I put the 3 here and the 5 here, or the 5 here and the 3 here? And I think what Julie was trying to say was, however you decide to put it, you can then test by multiplying across like that and seeing if they add up to this. So if I kept it this way, I'd have my 6x here, I'd have my 5x here. Does that add up to the 11x? Yes. So that means this, and it's going to be plus since I used a positive there, is one factor. And this, again with a plus because I used a positive, is my other factor. So that's one way of thinking through it. It's more of a guess and check kind of way. If your numbers are fairly simple and don't have a lot of factors to them, this isn't a bad way to do it. But sometimes you start dealing with numbers like, a 4x squared and a 60 over here, and it's like, okay, do I go with 2 and 2? Do I go with 1 and 4? Do I go with, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12? So that's when guess and check can get a little bit overwhelming, is if you have numbers that have a lot of different factor pairs to them. And it gets a little bit tough sometimes to just guess and check which ones are going to work. Okay? So there's a more methodical way to do this, which different teachers will show this different ways. So this may look familiar, it may not. Essentially, the math behind it is the same. The organization or the methodology that you're using can be a little bit different. Here's how I've taught it in the past. Okay? A couple of years ago, I picked up a trick, I guess, from a video I was watching. I was looking for stuff for class, and I stumbled across this video. And this guy was talking about Xbox. Whoops, that's an eraser. Let's try a pen. Okay? And so in the Xbox, you put your A times C product up on the top, and you put your B down on the bottom. So in this case, A times C would be 30, and then my B is going to be 11. And then you ask yourself, what are factors of 30, not just 15, but factors of 30 that are going to add up to 11? What are they going to be? 5 and 6. Okay. I'm going to do those in a different color. All right. Then, what you do with those can be a little bit different. And I've actually taught both in the past, and it's probably personal preference as to which one works better. One way is what's called splitting the middle. Anybody heard of that? Splitting the middle? Nobody? Seriously? Splitting the middle looks like this. I keep 2x squared. I keep 15. But now, instead of writing it as just 11x, I write it as 5x plus 6x, because those are the numbers that came from over here. Is this statement still equivalent to this statement? Yes. All I did was take 11x and split it up into 2 terms so that I now have a 4-term expression. Because with a 4-term expression, I can now do grouping. Any of you heard of grouping before? Okay, that's good. All right, so what can we do with grouping then? Just factor from each group. So what can I factor from 2x squared and 5x? And x. So x is going to come out in front, and what are we going to have left in the middle? 2x plus 5. Okay? Still adding in here. What happens if I factor the next group? What can come out? A what? 3. A 3. And what's left? And what do you notice?
You can factor 2x plus 5.
Right, so now I have the parentheses matching. Those parentheses are technically factors, right? It's 2x plus 5 times x. It's 2x plus 5 times 3. So that means I can take this common factor of 2x plus 5 and factor it out in front, just like I did with that x from this group, just like I did with that 3 from this group. As a common factor, I can pull it out in front. Now, if I divide out the 2x plus 5 from both of those terms, then what's left?
3.
The x plus 3. So this is a more systematic way of getting to your factors when the guess and check gets a little messy. This always works. If it can be factored, you can do this. Okay? If you're going through this process and you end up not getting a match here or something like that, then that probably means what you're working with can't be factored in the first place. Okay? So that's one possibility. Now, I've had some students that even that is a little bit like, whoa, dude, what'd you just do? I did what? So a couple of years, because I don't know how many of you know, I know a couple of you do because you had me, but I've been here, this is my 7th year now. For the first 5 years, I taught Algebra 1. Okay, I did it in 8th grade, and then I moved up and I taught it in high school for a couple of years. So obviously this is something that I taught in Algebra 1. So I tried to think, okay, so how could I simplify this even a little bit more? Like, how could I maybe organize this in a way that isn't so overwhelming, isn't so confusing? And so I went off of the X box, which is what the guy called it. He called just making that X an X box. I decided to upgrade to an Xbox Plus. I know there's no such thing, but pretend there is, okay? So an Xbox Plus said, we still do this first, right? Take A times C, get 30. Take B, 11. What are the two numbers there that we're going to need? Okay? And then you make a plus, which is basically a 2 by 2 box. Okay?
Xbox.
Yep, Xbox Plus. And in my box here now, I put the 2x squared up here, so we don't change that at all. And I put the 15 down here. And then I use the 5 and the 6 from here to fill in the other two boxes. So we can make one a 5x, and we can make one a 6x. Doesn't matter which one's which. But the two numbers here, instead of splitting the middle like I did here, they're filling in my other two boxes. Okay? And then the idea is actually the same, but it's just organized differently. We're going to factor things out. So if I take a look at this first column, what can I factor out of a 2x squared and a 6x? A 2x. Okay? 5x and 15. What can I factor out of both of those? A 5. Then I go with the rows. 2x squared and 5x. What can I factor out of those two? An x. 6x and 5x. What can I factor out of those two? And then you check, because sometimes the signs get a little funky. So you just have to double check. Does 2x times x really give me 2x squared? Yes. Does 5 times x really give me 5x? Yes. Does 2x times 3 really give me 6x? Yes. Does 5 times 3 really give me 15? Yes. So that means this is one factor of 2x plus 5. And this is the other factor, which is x plus 3. So, as you can see, it does not matter the method that you use or the organization that you use to get it. No matter what we do, the factors are 2x plus 5 and x plus 3. What you have to decide is which method makes more sense to you and which method is going to get you the answer correctly the largest percentage of the time. So if you're good at the guess and checking, you're fine with guess and check, you can handle it even when the numbers get ugly, great. Guess and check. Just show me that how you set it up and how you got your factors. If guess and check is not your forte, like honestly, I've just gotten to the point where guess and checking just frustrates me. So I'll usually do it something more systematically. If you can do it by splitting the middle and then grouping, great method to use. That's probably the one I use the most often, personally, if I'm just trying to factor stuff, because it was the way I was taught. So that was what I remember. But if putting it in this box formation makes more sense to you, you're doing the same thing. You're factoring stuff out, you're ending up with the factors just organized differently. So if this is the organization that helps you, use it. If this is the organization that makes sense, use it. If you're good at guess and check, use it. All I want is that you show me what you do. I'll take any one of those 3. I just want to see it. Okay? Questions? Just quickly. So any questions on this? So as we go, we're going to go through a couple more here. As we do, try out some of these different methods. See what you like. Even if you feel like you're a pretty good guess and checker, just try a split the middle on one of these. Just try a box on one of these. You might find that you really like the split the middle instead because it's so systematic. There's no guessing to it. Just follow the steps, you'll get to the factors. Okay? So anything else before we move on? Do a few more? All right, let's do a few more. Okay, try this one. Thought you were so smart, didn't you? This can actually be really, really easy. Can be. If you make the right first step. Oh. I know it should kind of go without saying, but I'm going to write that extra word up there. Factor completely. Make sure it is entirely factored as much as you possibly can. some of these have been around for a while, so probably do's and juice. Okay, go ahead and share with your group. If you're stuck with some help, and if you're not stuck, then that's where you agree with your answers. Alright, Harry, what'd you get on this one? What?
I didn't get this one.
You didn't get this one? Did anyone in your group get this one?
No.
No? Oh my goodness.
All three of us got this one.
So help him out. What would be a good first step?
Oh, take 2 out.
Take the 2 out. You've got to remember that when we are factoring, the very first thing you should always look for is whether there's a greatest common monomial factor, a GCMF, excuse me. Okay? Because if every term has some common factor in it, factoring it out first makes what you have left to factor easier. If you try to work with this 20x squared and this 36, I mean, if you're doing guess and check, you've got 1 and 20, you've got 2 and 10, you've got 4 and 5, I don't know which one to use. And then you go over to 36, and do I go with 1 and 36? Do I go with 2 and 18? Do I go with 3 and 12? Do I go with 4 and 9? Oh my gosh, I'm making myself dizzy. What do I do? Like, there's a lot of factors there to have to wade through to try to get to an answer if you leave it like this. But if you factor the 2 out first, what's that, 27? Then at least what you have to work with becomes a little easier. Because now the quadratic you're trying to factor has a 10 for A. Well, I'm either going 110 or I'm going 25. Like, those are my only 2 options. My constant is now an 18. Well, I still have 118, 29, and 36. But that's fewer options than what 36 had. So you're at least narrowing things down to make it a little easier on yourself. If you decide to do one of the Xbox kinds of methods, you're also now dealing with smaller numbers. Instead of trying to take 20 times 36, which is 720, and then try to decide what the factors of 720 that add up to a negative 54 are, you're right. I mean, even I would be going, no, don't think so. But now, 180 factors of that add up to negative 27, I might have a better shot at that. The numbers are just smaller to work with, which makes them a little easier to work with. So anyone do it that way? What would be the combination of factors from 180 that would add up to negative 27? Anybody get it? 15 and 12? So 15 times 12, that's a 10. That's, oh, nope, let's try 30. 15, 0, 8, 1. That looks good. And we would want to make them both negative, right? Because that's positive and that's negative. So if we were doing the Xbox over here, get this out of the way, we would have 180 on top, we'd have negative 27 on the bottom, and the 2 numbers that make that happen are a negative 15 and a negative 12. Okay? So if we continue with this idea, should I do the plus or should I do the split the middle? I don't care. Call one out. I don't
Middle.
care. Split the middle. Okay. So negative 27x is now going to become negative 15x and minus 12x. We're going to stay with the 10x squared out here, and we're going to stay with the 18 out here, and now we're going to group. Now when you group, in our last example, the sign in the middle was plus, so we just put the parentheses and kept the plus sign in between. When it's minus, we want to make it plus. So before you actually put your parentheses in, just change this to adding the opposite, and then include that negative inside of your parentheses. So that you're actually working with a plus here in between. Okay? So what can we factor out of 10x squared minus 15x? A 5x. Okay? So 5x is going to leave me with 2x minus 3. What can I factor out of a negative 12x and an 18? 3, 6. Which one would I want? 6. So if I take a 6 out, I have a negative 2x plus 3 left. Does that match? No. So that means I do not have the common factors I need to be able to factor the parentheses out. But it's so close. Can I make it work?
You take a negative out.
Yeah, take the negative out with the 6. So instead of taking a positive 6 out, take a negative 6 out. Right? That means it's going to be a positive 2x and then minus 3, and now I've got the match. Make sense? Okay, so now my final step is to factor out. So this actually becomes minus here. Right? Because it was plus, so if I'm taking that negative 6 out, it's actually a minus now. So my common parenthesis factor is going to be the 2x minus 3. And then what's the other factor? Is that my answer? Yeah, don't forget the 2. We kind of kicked 2 to the curb there for a minute while we dealt with the quadratic, but it is still one of the factors. It is still part of the answer. Don't forget about it. So 2 times 2x minus 3 times 5x minus 6 should be your completely factored answer. Now, some of you actually went through the work and managed to figure out from 20x squared and 36 what you should use. You probably have one of your two factors that has a common factor in those two terms. So you're not completely factored anyway. So why not take the common factor out at the beginning and make your life easier? Because you're going to need to take it out anyway. Either you ended up with a 10x minus 12 or you ended up with a 4x minus 6. Okay, one of those two is going to have that 2 taken out of it anyway, so take it out at the beginning and work with easier numbers. Okay? All right. So what happens then when we say we want to solve instead of factor? Okay, go ahead and give this one a try quick. Okay, share with your group. Alright, Carrie, second chance. What do we do on this one?
I got x equals 8 for 1.
And how'd you get it?
I moved the 9x and negative 8 to the side with x squared.
Okay, and how do we move them?
You add 8 and subtract.
Good.
Subtract 9x.
And what's that leave me over on this side then?
0.
0. So generally speaking, when we're solving quadratics, we usually want to get everything on one side equal to 0 on the other side. Especially if it's something that is going to be factorable. Because when we get to the point where we factor, what are the factors going to be? Anybody? Okay. When we get to that point where we've got the factors, we need this to be equal to 0 in order to use the zero product property, which says if I'm multiplying two things together and I get 0 as an answer, one of those things had to be 0. It is not called the 5 product property. It is not called the -6 product property. It's called the 0 product property. So we have to have our factors equal to 0 in order for the 0 product property to work. So usually we'll get everything on one side equal to 0 on the other in case factoring is going to work, because then we can use that 0 product property to actually state what the answers are. And now I can state what x equals because I am solving and I actually have an equation. So my x values are going to be what? 8 and what?
1.
And 1. Those are the values that are going to make each of these factors equal 0. And so those are the solutions to our equation. Okay? All right, share 2 groups. All right, Cheryl, what should we do with this one first?
First, you move the right side of the equation to the left, so you make it 9x squared plus 21x plus 10 equals 0.
Okay, so 9x squared plus 21x minus, plus 10 is what we end up with, right? Subtract the 8 equals 0. What do you suppose is the most common mistake that people make on questions like this?
They don't add.
They don't do the inverse operations and move everything over. That's pre-algebra stuff. Okay. Yeah. Now, I think what happens is what always happens, okay? I did this when I was in college. We get so comfortable with things that we did a few years ago, because we know it, that we stop really thinking about it. And so if our brain isn't really thinking about the steps we're making, we start making stupid steps, right? We look at negative 10x squared and we go, oh, let's subtract 10x squared, or 10x. No, you gotta add it to move it to the other side, not subtract it. So make sure you're paying attention and you're working carefully, because if you are to do any of those inverse operations incorrectly, then the quadratic you have left to work with is gonna be a mess. Okay? All right, so what do we end up with then for actual factors? Anna, what'd you get?
3x plus 2 and 3x plus 5.
Everybody agree with that? Curiosity, how many use guess and check? Anybody try split the middle? No? Anybody try the box? Okay. All right, whatever. It doesn't matter. Nobody's right or wrong. It's whatever you're comfortable with, whatever gets you the right answer the most often. Okay? So if these are our factors, then what are our actual solutions, Julian?
Negative 5/3 or negative 2/3.
And should we be changing any of those to decimals?
No.
No. If we're thirds, we're going to be repeating. These have just got to stay fractions. Okay? So is this really that bad? No. You just have to remember what your steps are. Get everything on one side equal to 0 first, and then factor things out. You'll be able to do it, no problem. Okay. Do you know what it means when a question asks you to do this?
Set y is
Find x.
0.
Yeah. So this is just another way of saying pretty much the same thing. Okay? When we have an equation where there's only one variable involved, then we're generally looking for solutions to that equation. When we have a function where there's two variables involved, we're still going to go through the same process of factoring and then finding the values that are going to make each factor equal to 0. But because it's a function instead of an equation, we call what we're looking for zeros instead of solutions. But the process doesn't actually change. And like somebody said over here in the corner, basically your thought process is, I'm just going to replace the y with 0 and then solve it. Those are the zeros of the function. So if I do that, if I replace this with a big old 0, how can I factor that? X plus 8 what? Squared is going to equal that 0. So this is another one of those that fits the pattern, if you notice that. If you don't notice that, then just go through the normal steps. But because I end up with x plus 8 quantity squared, what's my actual 0? Just a negative 8. This is one of the strange situations where we just end up with one solution because our factor was actually repeated. So it's the same solution for both. I don't need to write it twice.
And what's this pattern called again?
This is a perfect square trinomial pattern. Difference of squares pattern. So when it's like x squared minus 100, that's called a difference of squares pattern. When it's like this, it's called a perfect square trinomial pattern. And it's that a squared plus 2ab plus b squared.
What's it called?
Perfect square trinomial.
The a plus b and the a minus.
The what?
A squared minus b squared.
When you have a squared minus b squared equal to a plus b times a minus b, that's called difference of squares. And when you have a squared plus 2ab plus b squared equal to a plus b quantity squared, that's a perfect square, whoops, not a G, a Q, that's a Q, perfect square trinomial pattern. Okay. Nope, not that one. This one. I just want to show you this quick because it's similar to a problem in your book, and this type of problem always gives people trouble. So I just want to show you how to set this up. Once you know how to set it up, you should be able to solve it. Okay? And that's really the key with any word problems you get when you talk about quadratics. It's the setup that's tough. Once you get the setup and you realize you have a quadratic, solving it's easy because we know how to do quadratics. So here's a situation where it says a gym charges $180 for a yearly membership. There are currently 1,000 members. For every $5 increase in price, the gym is going to lose 10 members. So the question is, how much should the gym charge to maximize its revenue? So the first thing you need to understand just in general terms is, how do I find revenue? Revenue is just money we take in. It's not necessarily taking into consideration costs or profit or anything like that. It's just money we're taking in. How am I going to figure out revenue in this kind of situation? Just in general terms. Yeah.
Price times sales.
Yeah, so price times membership, right? So we'll call it P times M. The price per membership times the number of memberships is going to give us revenue. Make sense? Okay, so what is happening with the price? Currently the price is what? $180. What do they want to do with the price? Increase it by $5. So in this case, our variable is going to represent each time it changes, okay? Which is a strange thing to represent, but that's what we need it to represent. So every time that I make a change in price, I'm going to take $180 and I'm going to add $5 to it every time I increase, every time I change it. So that's the expression that represents what's going on with price. Okay? Now, what about membership? Currently they have what? 1,000. What's happening with membership? If they do this increase, what happens to membership? They lose 10 members every time. So what's that expression going to look like? Minus what?
10x.
Okay. So with every change of increasing $5, the change in membership is that we decrease by 10 members. Now, the idea is we want the maximum revenue. So what do I actually have to find from this thing? The vertex. And what form is this in?
Factor form.
Factored form.
Oh,
So you could go with the idea of figuring out what the x-intercept here is, what the x-intercept here is, and then find halfway in between. You could multiply it all out to get standard form and do it that way. You could plug it into your graphing calculators and have it help you find the vertex. But once you set it up and you know it's quadratic, then you've got all these choices on how to solve it. Okay? So there's one in your homework that's like that. Just wanted to show you that quick so you have an idea how to set it up. Please make sure caps are on your markers nice and tight. Whiteboards, markers, cloths, all those things should be back in the basket. Your homework is posted on Canvas. It's due for Thursday, and we do have a quick quiz on Thursday. It's over 4-1 to 4-4. So 4-1 to 4-4. 4-1 to 4-4. And it's posted on Canvas too. It says on there what we're doing, I think. If not, I will make it say so in just a few minutes.
This way we know what to study for.
Sorry?
So we post on Canvas and we know what to study for.
This is graphing and factoring, so it should be pretty easy.